Hey guys, so this week we're going to be talking about the area of two-dimensional figures, both regular and irregular. We are going to briefly touch on a composite figure type problem, but it's just a way of solving one of our normal polygons. So we're going to go ahead and get started. First thing we're going to do is our area of two-dimensional figures, and we'll start with the trapezoid. The first example they gave us. So we need to remember that the formula for area of a trapezoid is 1/2 base 1 plus base 2 times the height. You can also write it as area is base 1 plus base 2 over 2 times the height. I have seen it represented both ways. Whichever way works better for you. Just make sure you're not um, forgetting that the numerator in the first term in my second version is also a grouping, similar to the first way I wrote it. So both ways work. You can do it either way. Now, what are these different things meaning? We have base 1 and base 2. Those are our parallel sides, and the height is the distance between them. So in a trapezoid, which one is base 1 and which one is base 2 does not matter. Because I can flip this trapezoid on its head and it'll still be the same shape. I tend to just make the top one base 1 and the bottom one base 2. Doesn't matter to me. And then our height is this dashed line. It will often be represented as a dashed line, or if it is this type of trapezoid, which is a right trapezoid, the height would be that one. Okay? So it's basically the line that is perpendicular to both bases. So this is my H. So we're going to make our list and go ahead and do this problem. Okay, so here's my sketch of the picture we had before with a base 1 of 15, base 2 of 25. So we're going to write that down. Base 1 is 15, base 2 is 25, and the height is 5. And we're just going to take our formula, area equals, and I like base 1 plus base 2 over 2 times the height. That's my preferred way of writing it. All right, so let's plug into the formula. We have area is equal to base 1, which is 15, plus base 2, which is 25, over 2, times 5, which is the height. 25 plus 15, 40, over 2, times 5. 40 divided by 2 is 20, times 5. The area is 100, and then it's the units squared. So let's see what we have. All right, so area is 100 inches squared. All right, let's move on to the second example, which is our parallelogram. Remember, a parallelogram is a four-sided figure that has two sets of parallel sides. The formula for a parallelogram is area is equal to base times height. And then we also have to remember in a parallelogram that opposite sides are congruent. So that means AB is congruent to DC, and BC and AB and DC and AD and BC are congruent. So let's go ahead and work this problem out. All right, so in this case, they gave me a base, which is CD, and we know that's the base because this is the height. And so we need to figure out what this length of what the height is from B to D. And we're going to do that by using a Pythagorean theorem because basically the height would be this. If we continued this out, this would be our height. Okay, so it's the same as it is on the inside. So we're going to use our Pythagorean theorem, a squared plus b squared equals c squared. And we are going to have A is 15, B is our unknown, and C is 17. So we're going to have 15 squared plus h squared equals 17 squared. All right. And then we're going to go ahead and simplify. Okay, so now I'm showing you that 15 squared is 225, and 17 squared is 289. And so now we're going to subtract 225 from both sides, and we get h squared equals 64. And then we need to take the square root of both sides, and that tells me that h equals 8. We're going to use the positive square roots only because we're measuring a length, and you cannot have negative lengths. So we have base is 15, h is 8. So our area is going to be 15 times 8. 5 times 8 is 40. Put the 0 down, carry the 4. 8 times 1 is 8, plus 4 is 12. So the area would be 120. And because the units are not given, it's just going to be area is 120 units squared. You don't usually even have to put units squared. Sometimes you'll see that in the answer choice available. Okay, now finally we have the area of the triangle here. And the area of the triangle is 1/2 base times height. Base is going to be generally the side they're going to give you. The height is from the vertex, a vertex, to the opposite side, and it's perpendicular. So they gave us 6 as the height. It wouldn't matter which way you did it, it would end up being the same, but you'd have to calculate out your other heights and sides, and that would be a lot of work. So I would recommend just using the one they give you. The height is almost always represented with a dashed line unless it's a right triangle, in which case right triangles, the height and the base are interchangeable because they're essentially the same. Okay, so let's go ahead and work out this triangle. Okay, so on our triangle, we have a base of 18 and a height of 6. So area equals 1/2 times 18 times 6. And we can go ahead and multiply straight through. So 1/2 times 18 is 9, times 6 is 54. So some of you would rather write the formula as such, where area is equal to base times height divided by 2. That's the same thing. The reason I did it the way I did is that it's easier to multiply 9 times 6, just be honest. So that would be area is equal to 18 times 6 over 2. And 18 times 6, 8 times 6, 48. 6 times 1 is 6, plus 4 is 10. And so area would be equal to 108 over 2. And 108 divided by 2 is still 54. So it doesn't matter which way you write the formula, so long as you remember that eventually you need to divide by 2. And you only need to divide by 2 once when you're doing one triangle. Okay, so for some of the practice problems, what I'm going to go through is just to remind you which formula you're going to use. So again, the dimensions of a lawn shaped like a trapezoid. Your area is going to be base 1 plus base 2 divided by 2, all of that times h. H is the 4 meters. That is the hint I'm going to give you. H is 4, not 5. And your bases are labeled. Okay, so for number 2, the hint I'm going to get, a couple hints I'm going to give you is that you're going to find this by finding the area of the rectangle minus the area of the white triangle, this one. And also that AB is 9 units because it listed A to this point, and B to that point. We don't know what that point is, but it doesn't really matter. So that means DC is also a 9 units. The other way you could look at this problem is that the gray area is a trapezoid with bases of 4 and 9 and a height of 3. So if you want to use the area of a rectangle, which is base times height or length times width, area of a triangle is 1/2 base times height, and area of a trapezoid, terrible trapezoid, is base 1 plus base 2 divided by 2 times h. So if you're going to have the area of a rectangle minus the triangle, that's one way to do it. If you're comfortable with the trapezoid formula, use the trapezoid formula. Number 3 is about a parking lot in a shape of a parallelogram. The height is 120. That is the hint I'm going to give you. H equals 120. For number 4, you're going to need to go backwards. You have area is 240. Width is 15. What is the length? And you would just need to remember that area is length times width. And you will need to go backwards and figure that out. So plug in what you know into the formula. Number 5 is a little bit unusual. It is a kite. As far as the area of a kite, for me, the easiest thing to do is to break it into the two triangles when it's given to me information this way. So what I would say is I'm going to go ahead and label this kite A, B, C, D, and I'm going to use those letters for a point of reference, okay? So I would take the area of triangle A, D, C and multiply it by 2 because the area of ADC is going to be it's half of the kite. What that also means is you could do the half of the width times all of this length. The same thing. So this will be the H you'll use in the formula, and the base will be all of that. So make sure you get the information you need there. All right, so for area of regular polygons, they gave you the important information for all of the problems. You're not going to have to solve for it. So I will go over some vocabulary with you, as well as going through setting up the first problem so you can run it through a calculator. As far as the discovery piece where it told you how to find the apothem, I will run through that in another video. So the important vocabulary we have here is center, which is, of course, the center of the circle that would be drawn touching all the vertices. And then it goes from the center to the side. It's perpendicular to the side. And in a regular polygon, it also bisects the side. Then you have the radius, which goes from the center to the vertex. It would be the radius of the same circle drawn all the way around. And then we have the apothem, which is a line segment drawn from the center of the polygon perpendicular to a side. So make sure you know where your apothem is. So the important pieces of information we will need for this assignment are your apothem and your side length, because your side length tells you how to find your perimeter. All right, so number 1, we have a regular pentagon. Regular means that just as a reminder, regular means all sides are equal, and also the interior angles are congruent as well. So we want to know that every side here is 8. The formula for the perimeter of a regular polygon is the number of sides times the side length. So the perimeter for this, where n is 5 and side length is 8, is going to be 5 times 8. The perimeter will be 40. And then you have your apothem is 5. And your formula, of course, is 1/2 apothem times perimeter. So you can plug that into the formula. 1/2 times 5 times 40. And run that through a calculator. Okay? You'll do the same thing for all the rest of the problems. Since they gave you the apothem and the side length for every problem, except they did that for number 2. They have the side length of number 3 and number 4, and number 5 asks you to explain 2 different ways to find the area of a regular polygon. So I would say go ahead and make sure you watch the next video, because I will discuss different ways to find the area of a regular polygon. Or you can go through your past notes that we did previously, which should still be attached to Google Classroom. If you have any questions, please feel free to email me. You can call me, text me, whatever. That information's on the school website. And then you can also sign into the live chats on Tuesdays and Thursdays. Talk to you guys later. Bye.